Good afternoon, and welcome to today's Electronic Design and Microwaves and RF webcast. Our topic today is Extending Semiconductor Component Life Cycles for Critical Applications, sponsored by Rochester Electronics. I'm James Moore with Endeavor's Design and Engineering Group. To begin, let me explain how you can participate in today's presentation. First off, if you have any technical difficulties during today's session, simply type your issue into the Ask a Question box, and a member of our team will assist you. You can also click on the question mark Help button in the upper right corner of the screen. Additionally, we also welcome your questions during today's event. We will answer as many as possible during the Q&A session following the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the Ask a Question box and click on the Send button. If you'd like a copy of the presentation, please click on the Event Resources on the side of your screen to download the presentation. Also, please be aware that today's session is being recorded and will be available on the Electronic Design and Microwaves and RF's websites within the next week. You'll be notified by email when the archive is available. Now let's meet today's speaker. With over 35 years of semiconductor design experience, Daniel Dice is the Director of Design Technology at Rochester Electronics, based out of its Rockville, Maryland office. In this role, his group performs all authorized product replications and customer-specific design solutions. Daniel is also an active member of the Anti-Counterfeiting Task Force for the SIA, having trained more than 200 CBP and HSI agents. Now let me turn things over to our presenter. Dan, the floor is yours.
Thank you very much, James. I appreciate it, and welcome everybody to our talk today, our webinar, Extending Component Life Cycles for Critical Applications. Today, it's kind of a challenging time right now, and a very challenging time with demand in the semiconductor market. Everyone's heard about component shortages. Everybody's heard about how that impacts different places in the supply chain. And really brought about by many different things, including COVID. But there are industries that require life cycles that are 20 to 30 years, and industrial, automotive, medical, aerospace, and defense. And this is making it even harder for those industries to keep their supply chain moving forward, keep delivering products, keep recognizing revenue from system ships. And today, I want you to learn about options available to extend the semiconductor product lifecycle, and also learn about the pros and cons of each option and various services and solutions available. And I want to start out talking about the challenges for component engineers, really from a component engineering perspective. What are you facing today? Your suppliers are consolidating product lines. There's decreased production phase and increasing end of life. And you'd think, right, when the demand is so high that they would keep shipping product, no problem. But in reality, what happens today, while the market is seeing all this demand, it allows focus of product lines. So what happens is the semiconductor companies look at the increase in revenue as an opportunity to trim product lines that aren't meeting expectations anymore, and to focus and invest where they see the market headed. So we're actually seeing increasing end of life even today. While the market's booming, we're seeing an increase in end of life. We're also seeing major offshore assembly and test providers moving completely away from lead frame assembly. Anything to do with lead frames is eventually going away. You see this with the rise of QFN, but also with certainly a couple decades ago, flip chip came in, and it's really kind of all taken over with chip scale integration, multi-die integration, but all of it without lead frames. And there's also been a strong growth in fabless IC revenue. So, more companies are fabless. Now, what does that mean for you? That means that you're not going to have the overruns. When somebody used to own their own fab, they would more easily do overruns, and they would have excess product at the end that might save you when you're trying to get system shipped 20, 30 years after the fact. So that means that when you're fabless, you're not going to have as many overruns either. So that is another challenge for today's component engineers. So options to extend the life of a semiconductor. You know, you've got really three I'm bringing in here, but it's beyond that. But I think these are the three most common ones for sure. You got a last time buy and in-house long-term storage. The advantage of that is you got everything direct right there, but it is one of the most expensive ways to handle it, do it yourself. And it requires expertise that you likely don't have, and accurate projections. Going to your management saying, yes, we need to buy 20 more years of this product, I promise, is a tough proposition. You also consider near source components, although this is a dying thing. There aren't that many other than commodity products that are drop-in anymore. Couple decades, maybe 3 decades ago, when it was simple logic parts, that was an easy thing to do. You could find one logic part from one supplier, would drop into a slot of another logic part, and you were good to go. Rarely today are components dual sourced. It just doesn't make any financial sense to happen. So commodity products like flash and some SRAM, that can happen, but it requires still, you're going to want to do another qual. It can be expensive. It depends how fine-tuned that product is to your system software. And then the last option, it's working with a licensed manufacturer who is authorized to continue component supply. And this requires knowledge. So everything that the company I work for, Rochester Electronics, has ever put in place was really driven by either customers or the semiconductor companies directly. And in order to extend the life of a product when you're a system level OEM, going it alone doesn't make as much sense anymore as it may have in the past. Really partnering up, working with a licensed manufacturer is the way to go. You got multiple options available, exact same component indefinitely, but you need to make sure that the supplier is 100% authorized and that they've got the expertise to handle it. So we've got three manufacturing facilities at Rochester. We've got the corporate headquarters, what we call Building 9 and Building 10. And really what we've expanded upon here that we want to bring to this webinar is a whole bunch of manufacturing capability that 3-4 years ago there was just a dream of that happening. But normal stuff been in place for a long time, a test lab, burn-in lab, and so forth. That's in the corporate headquarters, and wafer die storage. And I'll go into a little bit more later about what we have in wafer die storage. Building 9 is really home to plastic assembly for us, lead and plating and lead finishing and that kind of thing. Remember, I said earlier that lead frames are going away. Well, what does that mean, lead frames going away? That means all your dips and quads and PLCCs and all that eventually are going away. And we know that they've been diminishing in quantity from the largest of the assembly houses, Amcor and ASAT, for a long time. And there's been obsolescence happening. So Rochester needs to pick it up and continue to enable lead frames. And plastic lead frame technologies in Building 9 is where we are. And Building 10's been doing Hermetic for a few years now, several years actually. So our die wafer storage is unrivaled. 12 billion die in stock. That's not an exaggeration. That's probably an understatement. And wafers ranging from 2-inch wafer to 12-inch wafer, and where the max is today, and actually for 50 some odd years of storage. And you say, well, wait a minute, Rochester isn't a company that was founded in 1968. That's absolutely correct. everything in there came directly from the semiconductor companies. But when we started in 1980 or so, there were already wafer under storage at some of the semiconductor companies that Rochester took control of. Temperature and humidity controlled, access restricted, and it's a next generation storage plan in place to handle up to 30 billion die, because we do see that with our increased number of semiconductor companies we're working with every year, and more recently with ST, we see that probably there's going to be a demand for a lot more wafer storage than what we currently have. So we've been putting that in place. And this isn't just we do this as a casual thing. This is a massive thing and proven long-term reliability. There are far more expensive storage methods out there in the world, but we found that is not needed, and we can prove it. So be interested to talk to anybody that's got wafer storage needs. We can show you that we've been doing this for longer than anybody else, and with more quantity under storage than anybody else. With that die wafer storage, you got to have a way to process the wafer, and that's back grinding and dicing. And we have the ability to do both of those in-house and quite extensively. So we've invested again to continue extending the life of our product all the way through the cycle, and that includes the wafer processing services and back grind and dicing and waffle pack and everything else that you might want to do with wafer processing services. Just as a reminder, again, I know that the host told you at the beginning, if you've got questions, ask them. I'll do the best to answer them as we go here. More on wafer die processing, die sorting as well. We have the ability to do pretty extensive inspection capability. We've invested a lot and really working directly with a major semiconductor company right now, doing some inspection on long-term storage product, and so we get involved in all kinds of esoteric and needed wafer processing services and inspection services that help, again, extend the life of a semiconductor product. Moving on to Hermetic assembly capability, you got to know that Hermetic assembly, more commonly known as ceramic or metal can, but this is also where you can get a little more esoteric packaging available. But we're commercial and military flows, QML certified for ICs, in-house reliability testing, qual services, and really Rochester's been providing full-on QML certified product to military customers for decades. So we know what we're doing in that area. In plastic packaging, this is a more recent investment in the last 3 to 5 years, ramping this up. Fully automated and semi-automated mold equipment, die attach, wire bond equipment, lead frame options, including design replication. So you probably have packages and assemblies that are no longer available. We have the ability to reverse engineer some of those. And it's just a matter of getting the data and figuring it out, or doing teardowns and figuring it out, which we've done that as well. We manage direct engagements with the largest assembly houses in the world. And so we have access to a lot of OSAT partners as well, who are more than willing. In fact, some of our plastic packaging automation was originally at the external subcontractors, the OSATs. So we kind of know what's going on there. So, all right, lead finishing. One of the, Amcor is a good example. They're no longer doing tin lead. at all. So no tin lead available there. But the demand for that is still out there. So we have finishing as well as solder dipping options for product. All kinds of flexibility there with low volume, higher volume, and capable of RoHS to tin lead conversions. You know, our test capability is a little bit unusual. You look at what a test house wants these days, and what they want is homogeneous equipment sets. They want the same equipment set so they can get expertise going and build it up and kind of everybody cross-train and so forth. Because of Rochester's lineage of handling products anywhere from the 1970s all the way up through the 2000s, we have acquired and currently have many different test platforms because the original product needed a specific test platform in order to be extended. And that's what we have in-house, a lot of different test capability, a lot of varying test program capability. We have industry standard test equipment, and automated handlers that we're investing in right now to bring us forward. We're not just an old set of equipment, but I wanted to emphasize the extensive set of test equipment. Sometimes people obsolete things for test equipment reasons, and we're able to continue to provide that product because of no test equipment obsolescence, which is another reason for obsolescence. Another capability we've got near and dear to my heart, because this is the group I get to run here at Rochester, is design engineering. So we're the method of last resort. When you take a look at everything available from Rochester, from wafer die storage to manufacturing, which is assembly and test capability, we're the method of last resort where none of that is, you don't have the original wafer anymore. I'm lucky enough to have a group here with over 350 man-years of experience, and if you kind of roll that out, what that means, that's a tremendous amount of design experience for one group. We're really good at design closure, test generation, layout, DRC, GDS2 editing. Some of what we do is device cloning, fully authorized device cloning. So everything we do, the original Semiconductor company actually enables us or authorizes us if they don't have any archives. And we've got extensive software tool knowledge, electrical and performance replication. We've done a lot of DO254 minor change classification, DAL-A projects, which is pretty good when you think about it. We're able to replicate a device and provide a proof of that duplication methodology in several DAL-A projects. And DAL-A is Design Assurance Level A. For commercial avionics, that's the highest reliability product, and we've been able to replicate those products. Just some quick pictures of successful replicated products we can talk about. About half of them have had some analog content. We don't run away from analog content. We can handle that very well. But it varies all the way from millions of transistors to much smaller products, but they're kind of tricky maybe from an analog perspective. Varying all over the place. We're currently looking at 130 nanometer projects because that's kind of where end of life is happening more frequently, and all the way to way older 5 micron enhancement depletion NMOS, and we've had to deal with that as well. Quite a challenge to deal with such a wide technology variance coming in. Essentially, it's every technology from every semiconductor product that could possibly be ported to another foundry. And our process is rather unique. We don't, it's not a new layout necessarily, especially in a cloned product. It's not a new layout. So we do a lot there. You can get a hold of us, and again, check the reference material we've sent. We've gotten the side links you can download some material, but always feel free to ask us questions too. So we're a licensed manufacturer. Everything we do is authorized. Nothing about Rochester Electronics is, oh, we're going out on the market and we're buying parts and then we're selling it. Everything is authorized, 100%. It's not many aftermarket manufacturers that can say 100% of what they do is authorized, but that's true with Rochester Electronics. We have built to stock, built to order, product replication, many different options for licensed manufacturing. Got some customer success stories here. 68040 is a very famous processor from Motorola days. RF test solutions we've done and so forth. So hopefully today I've given you some options. It's a really difficult environment right now as a component engineer. You're at an OEM, you're getting these end of life notices accelerating. We can give very good insight into long-term demand and help with key applications. I think, again, I'll emphasize everything we've ever put in place at Rochester has been customer driven. We're not going away. We've been here for a long time. We're going to continue to be here for a long time. We're putting in place systems and solutions to ensure long-term product life. We know lead frames are going away. We're going to handle all the lead frame assemblies and so forth. So got insight into supplier relationships, technical expertise, and experience to extend the life cycle. So with that, I kind of want to turn it back to our moderator and let him throw some of your questions. I see questions have been coming in, so that's great. But I'll turn it over to the moderator right now.
All right, since a few of you have already submitted questions, we're going to jump right in. If you'd like to submit a question, type your question into the Ask a Question box and hit the Send button. Also, please take a moment to complete the feedback form that will appear on your screen at the end of the webinar. All right, so the first question we have here is, can Rochester's die stock be searched on their website?
Yes, absolutely. Yes. And not only, one of the things that working with us directly might give you insight into is that some of the things that don't show up is if you're looking just for a part number, okay, and you're doing a search just for a particular part number, that may not be the best way to go about doing it. Working with us directly, we may do a search more on attributes. And what that may open up for you in that situation is the ability to take a product that was one semiconductor supplier, but bond it out differently and test it differently that kind of mimics what you're looking for. So, especially in logic parts, there might be more options, but you got to work with us directly to find out those options. Go ahead.
Okay, so the next question we have here is two parts. Do you have some graphs on cost versus time versus volume? And do you have any sort of special relationship with analog devices?
Cost versus, what was that? Cost versus?
Versus time versus volume.
Cost versus time versus volume. It kind of depends what exactly you're talking about from a product replication perspective. Is it from a purely a manufacturing from die wafer perspective? I don't know, but we can work up those numbers for whatever case you have. Do we have generic numbers? No, heck no, because every product is going to be very specific and every product is going to have a unique cost trade-off as well. For example, you could see that there may be product that is completely driven by the test solution. It isn't driven by the silicon at all. Or the assembly. It's completely driven by the test solution. And we've got the other way around where the product is entirely driven by the assembly solution. If you're gonna be asking us to put a product in that was in a 240 ceramic quad package, for example, I can tell you that it's not silicon driven at that point. It's all package driven from a cost perspective. So generic graphs are tough to come by. And then I can also go to the silicon side of things. If you've got some esoteric fab process where the silicon or the die is large and the silicon becomes the driving cost factor. There are lots of different ways to view this, and just work with us. Just ask us what you're really after, and let's see if we can take care of you. So.
All right, so the next question we have here is, what would the process be to transfer an old ASIC currently being made by another manufacturer to Rochester Electronics? How long would that process usually take?
That's such a beautiful question. Thank you for whoever asked that. Because we've done that. We've done that quite a bit of time. Get a hold of me because I've before I worked at Rochester Electronics, I've been here for 13 years. I started the design center. I was 20 years at LSI Logic. So I guarantee you I've got an answer for you. What it does come down to is it depends what you want to do with it and what your archive is. How much of the archive do you have right now in-house? If you've just got RTL and constraints, that's one solution. If you've managed to archive the GDS2, that's another set of solutions. If you've integrated a ton of IP, like you've gone out to Synopsys and bought some IP, you've gone out to somebody else and bought some IP, you got an ARM in there or whatever, that's yet another layer of complication into doing it. But yeah, we've replicated several ASICs. We do have about 20,000 LSI Logic ASIC designs for which we're authorized to replicate. So that's all kind of part of what we have done in the past. So hopefully come back to us with specific questions and we'll be good.
Okay, so the next question we have here is, for lifecycle designation RE active on your website, does this imply you are actually creating the parts start to finish versus packaging existing die?
It could be either. RE active means that it is an active product. We have wafer stock. That wafer stock may or may not have been a replicated product. So it could be either. Again, ask us specifically about the history of a particular product, and we'll have an answer for you.
All right, so the next question we have here is, you mentioned that Rochester has relationships with key suppliers. Can you elaborate on that?
Yeah, there's somebody asked earlier about analog devices, and I have to say we've got a multi-decade relationship with ADI. They're physically close to our corporate headquarters in Newburyport, Mass. They're also in Massachusetts. That's a very key supplier of us. TI as well, and most recently ST and Amplion. Amplion does very specialty high-end RF products. And ST, I think everyone knows, they have an incredibly broad portfolio, and we're very proud to have just inked an agreement with them as well. So it's like 70 different suppliers, companies that no longer in existence, but that's what you get with a multi-decade company who has tried to forge relationships with the semiconductor companies to continue to extend the life of their products. Pretty extensive list. So thank you for asking.
Okay, so the next question is, with regards to storage services, does Rochester perform quality checks on wafers that have been stored over a period of time?
Yeah, we have to, right? It's a good question. Given that we've got wafer that's 2-inch and we've got wafer that's 12-inch, and given there are alternatives out there that talk about doing all kinds of esoteric special materials and all kinds of stuff, we have been doing and continue to do QCI checks, bond pull, all that stuff, and take a look at any kind of growth on the material, whether or not it's still bondable or not, whether or not it's still manufacturable or not. We have to, and we do, and we've got data to prove it. And that's a lot of decades of wafer storage, guys. So I don't think you're going to get a more stable and better managed system than what we have here.
Okay, next up, you mentioned that Rochester provides tin lead finishing on components. Why is that required?
Well, the old tin whisker thing, right? Lots of people still want tin lead finishing. Part of it is tin whisker. Another part of it may be their board level assembly solder flow, temp profile when they do their solder flow, assembling their boards. Sometimes if they've got an influx of RoHS, but they suddenly get they're going to have the need for tin lead, or their profile simply won't work anymore for manufacturing, and we got to take care of that. That's all part of what we see happening, which is lead frames going away. Tin lead's part of that whole thing. So, okay.
All right, so we have another question here that is, what are typical obsoleted components that Rochester is authorized to reproduce / supply?
Sure, I hinted at that, and I assume this question is related to things that no longer are in wafer stock at all. And what I said is that a typical is going to be 130 nanometer or larger geometry, not newer geometry. If you think about it, what fab processes are available today at TSMC or Samsung or SMIC or any other tier one foundries, and you take a look at what's available there and what's not available there, and you can see that pretty much older than 65 nanometer they've kind of shut off, and so where Rochester's focused on new silicon versions of older product is where the tier one foundries have shut things off, and we need to continue to enable that product. So a lot of it depends on the original semiconductor manufacturer. Okay, if they don't want to enable us to do something with a product for whatever reason, then we're not able to do it. But those who say, yep, we'll enable you guys, go ahead, there's a royalty back or whatever, there's a business agreement back, those typically are where the tier one foundries have shut the fab processes off, and we're quickly following behind.
Okay, so I think we have time for one final question, and it is, does Rochester have its own internal fabs? And if not, are there specific foundries that you use?
Well, no, we are fabless, and we are not, when it comes to the end of life of a semiconductor product, or toward the end of life, or extending the life of a product, the volumes are not going to be what they were to begin with. So we usually cannot get into, or wouldn't get into, a TSMC or a Global Foundries for good reason. Their processes are way beyond what we need, and probably not a good match technology-wise. So we use two foundries today primarily, but there are others depending on the fab process we have to go to, and those are X-Fab and Key Foundry. Very proud of those partners of ours. They have a fairly broad process match, and you can also see they don't compete with TSMC and Global. But they differentiate at older process nodes and specialize in automotive, and that's where Rochester's headed. We're going through our certification process and expect to be there by the end of the year. So they're very much Key Foundry and X-Fab are very much in line with where Rochester is right now.
All right, thanks, Dan. Well, I'm afraid we've run out of time, but for those questions we didn't have time to answer, we'll be getting back to you via email. And so that concludes today's presentation. On behalf of Electronic Design and Microwaves and RF, I'd like to thank Rochester Electronics for sponsoring today's event, and of course all of you for joining. Have a great rest of the day.